everyone. Thanks so much for joining us today. I'm super excited to, as Megan said, geek out today. The flow for me will go, I'm going to acknowledge some really important people who have helped me along the way. I will go through some quick assumptions. I will then jump into a website I made for the Hiawatha National Forest, or let me correct myself, a web report that I made for the Hiawatha National Forest, focusing on some of the visual aspects of it and talking a little bit about the approach I took to make those. Then I will jump into RStudio and show you my workflow there. I'm not going to bore you with a lot of code. And then I will turn it over to Mark, who's going to help me take my work to the next level. And let me say this too before I jump into the website. A home run today for me would be to hear from you all about how we can work together to better use R with LANDFIRE data. So I would love this to lead to some kind of online workshop where we're sharing code, sharing strategies and approaches, because I'm definitely a programming hack and look forward to learning from you all. So with that, I will share my screen. The first people I want to acknowledge are some folks I work with the Conservation Data Lab. They're a group of young professionals and students who spur me on, challenge me, ask great questions, and help to keep me current and help keep me learning. So I just wanted to highlight those folks, especially this guy, Miles Wallema. Here's another picture of him because he did a lot of the heavy lifting with the code I'm going to share with you today. Just a tremendous human being and a great coder. I think the guy can learn anything given enough time. He's incredible. So here's the website or a web report, right? I don't know. I feel like it's important to say it's a web report. This was, a quick 2-hour teaser for the Hiawatha National Forest. So I love getting a call from a landscape where they're like, Randy, can you introduce us to LANDFIRE data for our landscape? Or Randy, can you help us understand the historical ecosystems and disturbances of our place? Can you help us understand how they're different from today? I love that. And how I used to work would be to get the data from LANDFIRE, bring into ArcGIS Pro, that would be now, it'd be ArcMap in the past, do my processing and some map making there, then go into Excel to make the charts, and then maybe into PowerPoint. Clearly that works, but for me, it was slow, it was hard to be consistent, and it also resulted in a PowerPoint that was not interactive and sometimes a big file for people to share. So I got feedback that a web report like this would be nice. My Forest Service colleagues can just send around a web link and they can play as much as they want, and it's easy. So as I mentioned, this is just a 2-hour teaser for my colleagues at the Hiawatha. So what this leads to are conversations, truck rides, and then further digging into LANDFIRE data. This is definitely not some complete in-depth analysis of the Hiawatha. The first visual I have is just a basic map of the area of interest. And it's just super simple, a shapefile presented in leaflets so people can see what the area of interest is. So super simple approach there. The past and present tabs are very similar, so I'm just going to show you one. I'm going to dig into the past tab. LANDFIRE digs into the past by way of biophysical settings. All right, so those basically this is how we map historical ecosystems, and we also have state and transition models that go along with those ecosystems to help us understand historical disturbance regimes. So basically in this web report, I have the text you see here in a table of contents. And if we scroll down, I have a basic chart of the top 10 biophysical settings for the Hiawatha National Forest. So in my cropping and masking of the biophysical settings data, I also generate kind of custom data tables that have all the data and that also kind of filter by the top 10. I like to do this in a teaser just to really kind of set the stage for the broad context of the place we're working. We can dig into the other biophysical settings. I think there are like 19 total, but these top 10 cover roughly 90% of the area. And that's almost always the case. Wherever I work, I find that a handful of ecosystems cover the area. I don't map in R, but I do all the data processing, the cropping, masking, and working with the legend material in R. Then I make the maps in QGIS, which I like to do. I think it's fun and it works well with my R code. I would like to work up to having something interactive in the future. But again, for this teaser, I think these maps are really nice and easy for folks to view. So I'm going to skip down. I have a few more very similar items, and I'm going to skip down to one other chart that I've enjoyed figuring out. I use the Crosstalk, Plotly, and GGPlot packages to make this interactive chart where someone can click on an ecosystem in the dropdown and get a chart that estimates the annual acres of the disturbances historically, modeled by LANDFIRE. And as I say, I'm realizing I forgot to tell you my assumptions. We'd love to talk about LANDFIRE data later, and I'm assuming some understanding of LANDFIRE or some patience on your part. And now I'm assuming a little bit of understanding of R, like when I mentioned packages, you know what that means. So I'm happy to dig in deeper with those topics later if you like. But this, I think, is really a helpful way to present the data. Again, it's a little bit interactive. Then I have the data table served up using the DT package. So then the last thing I wanted to show you on the website was this comparing page. This took a little bit more work on my part. Again, not being a programmer, being kind of a hack with R. This was more difficult, so I'm happy to share the code if you think it would help you. The first thing I wanted to do was to broadly compare historical ecosystems to current. And it was really important to me that we had these 4 paragraph signs. No, I'm totally kidding. I cannot figure out how to get those out of my chart, but at least they're not too bad. What you can do in this chart is we can explore the areas that were mapped by LANDFIRE as conifer in the past, for example, and see what they are today. So if I hover over what was formerly conifer, at least mapped by LANDFIRE, I can see that most of those areas are still conifer, though some have transitioned to hardwoods, presumably because of fire suppression. That's another common pattern we see in the United States, is a transition from conifer to hardwood over time due to fire suppression. So some people love these charts, some people despise them. It's really interesting, but I present it, I think it's a fun way to show broad transitions over time. And what this required was that I combine the historic and the current data together. I do that in R. Again, happy to share you the code. That took a little bit for me to figure out, but I wanted each pixel to have a value from the past and a value from the current. So you kind of have that fidelity up the pixel, if you will, or on that piece of ground to say what it was and what it is today. Digging a little bit deeper into our ecosystems, LANDFIRE provides just amazing data sets and models to help us understand the past compared to current. So one thing we can do is for each ecosystem, we can look at under and over representation of succession classes or serial states for all of our ecosystems. So this chart does that for the top 6 biophysical settings. And remember, this is just a teaser, right? This is a conversation starter. So I can look at the hardwoods and I see a pattern that's common across the Northeast where we had modeled that there would have been a lot of this class D, which I can tell you are the closed canopy tallest succession classes. We don't have any of that on the landscape today for the Hiawatha, at least as mapped by LANDFIRE. And we have what you might say is an overrepresentation of class E. As a teaser, I don't say what these classes are. Those are for further conversations, or for the Monongahela, I dug in a little deeper, the Monongahela National Forest in West Virginia, that is. At their request, after doing the 2-hour teaser website, I added this S classes tab where we dig in a little bit more, and I have a little bit of a description of these succession classes, and then a little bit of summary information, and then they can download the full description of the ecosystem here. And I'm trying to implore people please read the full description. You know, when I present these web reports, I tell people, again, it's just a teaser. There's so much behind this that LANDFIRE gives out. So anyways, those are the kind of the web reports and what they look like and what I'm doing with R in that regard. And let me show you how I've got this set up. Then I'll quick turn over to Mark. This code, again, was largely written by Miles Wallema, former student here at Northern Michigan University, where I sit. And what I have is I have RStudio. This is where I work. And I work in an Rmarkdown file for my data processing. So I get this outline. I find it's easier to read and follow, and I can keep notes. I have my inputs directory where I have my LANDFIRE CONUS level inputs. And this is where Mark is going to show us a great improvement for this workflow. I have these data sets stored on my computer, and every time LANDFIRE does an update, I have to go get new inputs. And Mark has written some code that's going to help with that tremendously. Looking forward to learning more about that. And I've got my input shape files for my analysis area. Then I have a folder of outputs. And again, I've got my Hiawatha National Forest. And so the code in this Rmarkdown file generates all the files for mapping. It generates all the attribute tables. And it also does some just starter charts such as this. So if I don't want to make a website, I still get the charts cranked out. And it's so fun because it just like, you know, I can't even drink a cup of coffee in the time this runs. You know, it just takes no time to run the code. Once I get those outputs, as I mentioned, I make the maps in QGIS, and then the website is set up like this. Again, in RStudio, I've got basically a Quarto file. I've moved from Rmarkdown to Quarto files, and this is what that looks like. You know, I've got just normal English text here. I've got headings. I've got my code chunks, and I render. And when I render, it produces HTML files, such as you see on a website. And then I have this basic skeleton that R uses to place all those files onto, basically, to see the architecture that you enjoy when you go to a website. So that's my basic tour and basic kind of workflow. So as I mentioned, I have all my files on my hard drive. And what I'm going to do now is turn it over to Mark to show you his code. And I see some chats. Okay. All right. Code is never boring. All right. So with that, I am going to turn it over to Mark.
Great. Thanks, Randy. Just share my screen real quick here. Cool. So yeah, as Randy mentioned, I've been kind of working on trying to figure out the best way of accessing the LANDFIRE API directly through R. And I've been reasonably successful with a function that we'll probably share around. If you're familiar with kind of the LANDFIRE Product Services API online, it looks something like this on the left side here. And I've tried to recreate that as, arguments in an R function. So for the layer list, we have a products list. The names can change eventually. The area of interest is AOI. It takes the same arguments as you'd expect online. So the latitude and longitude in decimal degrees, or a LANDFIRE map zone. Also can ask for a different projection as a well-known ID, or a new resampled resolution. There are two arguments I haven't gotten around to yet. The edit rule and the edit mask aren't quite functional yet, but I imagine I'll get them up and running fairly soon. There are a couple R-specific arguments that you want to be aware of if you use the function. So one is a path to some sort of zip directory, so somewhere to download the file to. If you don't include it, it'll just create a temporary directory for you. And then the other one is max time. So that's just a way of, if you ask for a lot of data and it's, taking a while to chug through, not having your R just completely, stuck, going nowhere. It'll eventually time out and give you an error. So I'm not quite daring enough to run code live. So I've used a Quarto document to create this for you. But just as an example, say I'm asking for 3 data products. I just picked 3. So forest canopy cover, elevation, and vegetation condition class. In an area of Northern California, which would be my AOI, I want that reprojected to NAD83 California Elbers and resampled to 90 meters of resolution. So if you were to do this online, you'd put all of that into the LANDFIRE Product Service API. Since there's a function in R now, we just list the product names in a character vector, our area of interest, and then the well-known ID and resolution. And then that one kind of thing I warned you about, you need to have some sort of save file. So in this case, I'm just creating a temporary file. And then if you call the API, what you get out of it is exactly what you'd see online. So it prints the informative messages as they show up. It updates every 1/10 of a second. So it's pretty similar to what you'd expect to see using the online version. And once it succeeds, it'll download the files for you automatically into whatever save directory you gave it. A couple of things to be aware of. If you used a parameter that's not compatible, right now it will still submit the call. So for example, 00001 is not a well-known ID. So if you called that, it will start updating. I'll start going through the process, and eventually you'll get the same error you'd expect online. So in this case, the input is not a geographic or projected coordinate system. And then R itself will also result in an error as soon as it sees that the job was failed, and it will tell you that it was failed, and you'll have to go back up and look and see what exactly happened. The only other kind of weird eventuality that you might come across is if you exceed the maximum time. It's not a huge deal. You can always change the time to whatever you want just with the max time argument. But also, as soon as you hit that maximum time, it will print out the URL to go and download the file for you, or that you can visit to go download the file. And it would be just like you're downloading it if you made a API call online. But with that, I wanted to give a quick example. It is somewhat code heavy, so I'll kind of gloss over parts of it, but of why it, beyond just the convenience of being able to download data directly in where you're coding and where you're working. And that's doing things like automating processes or automating reports. So in R, you can schedule a script to run, every day, every minute, every month, whatever you want, using, a package like Task Scheduler, or you could use cron if you're on a Unix machine. That works as well. But for this example, I'll just look to see if there are any new B observation records. That's mostly what I work with. So that's what I'm most familiar with, but this could be any kind of point data that might be, time sensitive that you're interested in. So one thing that I thought about would be, maybe firm's thermal anomaly data that's updated every 3-4 hours. You could look at their, the NASA API and download that data directly. So there are a couple ways of doing this. You could set the date programmatically. This is fancy code that just says what was the date yesterday. But for this example, I'm just looking at one specific day because there aren't very many bees out. So I wanted to make sure that I had a day with some bees. And then all I'm doing is checking in an online repository to see if there are records. And what we see is that there are a couple records and have their locations. And then I can map those. And if you map them, you'll notice that there's a couple, there's a cluster of points down here in Yuma, Arizona, where somebody went out and found some honeybees. And then there's also a point way up here in Phoenix. So if I was to ask the LANDFIRE API to download the data for these points, just as drawing a bounding box around them, I would be wasting a lot of computational power and memory space. So instead, I can cluster the points with just hierarchical clustering, and you'll come out with 2 different groups. 4 of the points are in one group. 1 of them is in its own group. And when we zoom in to Yuma, you'll notice that all of the clusters, all the points are in the same cluster. They're all blue, so they're in cluster 1. And the 1 point in Phoenix, if I can find Phoenix, is up here and it's orange. So that's just a way of kind of limiting the amount of data that you'd have to download if you were to do this. You can then get an area of interest for both of them. And then just as I showed above, but slightly more complicated, ask the LANDFIRE API for data around those points. And we'll get 2 successful calls. The first one succeeded and the second one succeeded, which is great. Can load the data in. And what we'll see is that now I have these small little raster files around the points in Yuma and a small little raster around the points in Phoenix. And I didn't waste, a bunch of space or time trying to download a really large data set. And then the great thing about being able to automate this is you can then go in, figure out what the environmental variables are at the point of interest. In this example, I chose really boring ones, so aspect, elevation, and slope. Then you can automatically just append that to a CSV. And so if you were to, automate this and let it run, it could constantly be checking for new occurrence records or new, points of interest, whatever those may be, and downloading the right data for the right location and just adding it to the end of a CSV. So I think there's a lot of kind of interesting things that we can do with the API, and right now it's functionality is almost equivalent to the online version, but hopefully everyone else will find some interesting uses for it, and I'd love to hear about any improvements or what other people are looking for.
Yeah. So Sabine, I'll ask a question for you. Sabine said she'd love to see a full assessment report from Randy's work for the National Forests, understanding comparisons and analysis that could really streamline that. And Randy, do you want to put the links to your website?
Yeah, definitely. Good call on that. We'll definitely do.
Mark, do you want to address Catherine's question here? Could you talk more about a reproducible JSON or API calls to keep data flows consistent? What are best practices for that?
Yeah, I mean, right now it's just calling the API exactly like if you would put it online. I'm not 100% sure how to best make it kind of a little bit more reproducible so you get the same versions through R, but that is something I'd be interested in trying to figure out how to do. I'm not sure if that answers the question, but.
We're far from having this office hour over, but I'm going to launch the poll because the first question is, how would you all like us to share this code with you? So having the answer to that question will help. But yeah, that was one of the first things we were curious about, because we know you all are here to learn about this, but better yet, let's not reinvent the wheel. Let's sort of piggyback off of Mark's code and Randy's code. So we'd love to know how we could share this with you all and what would be your preference. So you should see the poll on your screen. Can you guys see it?
Yeah.
Okay, good. And feel free to minimize it once you put your answer in there.
Yeah, I will definitely second Megan's sentiments. I would love to share the code. I'm not sure how to best do that, but I would love to do that. I would love to learn from you all on how to make the code better. So I'm not just going to ChatGPT, for example. Kind of kidding there, but I know my code could be more efficient and definitely commented better. So definitely keen to collaborate with you all. I've thought it would be fun to, have even a bit of a workshop where we share code, share ideas, or I'm happy to spend time with people to go through this process for a place. If you have a place you want to try it, I would love to do that. I want to do that, for example, with some students, because I'm sure that will expose all my holes and gaps in knowledge and ways to make things better documented if I were to teach it. So really looking forward to that.
Hey, Catherine, can you talk about what's a I don't know what RopenSci package is.
So. Yeah, sorry. Our OpenSci is, you can kind of think of it as peer-reviewed code packages. And so maybe you'd start it as like an open GitHub repo where people could submit pull requests and things like that. And you could sort of wrangle it into an OpenSci package. And the great thing about that is, there's just like additional support and review with regard to like debugging and testing and things like that. I can share a link to
Catherine.
the effort, and it's great. And like other organizations like USA National Phonology Network and others, like I've worked with them on like packages on our open site, and it is kind of a great platform just because it has that debugging support, and then it's kind of a good standard place for, say, ecologists to go look for packages for these types of like workflows. So I think it might be a good home.
And Catherine, I recognize your name, but can you tell the group where you are and what you do? Yeah, actually, Randy, I met you like forever ago. I met
your name looks familiar.
Yeah, I'm at Northern Arizona University and Vibrant Planet. And we have a couple of other people here on this call that are in the same boat, like Ethan and Ryan Anderson. But we mostly are looking at, disturbance patterns across the Western US and how they affect things like biodiversity and water and vegetation cover and things like that. But yeah, and for better or worse, I've kind of published some of these notebooks and things. And so that's why I have a lot of ideas, but we can also follow up with those like outside of office hours, which would be awesome.
Wow. Well, outstanding, Catherine. So Jim asked, how can the group continue to communicate and learn from each other? I would love to hear from you all about how you would prefer to do that. Megan has your emails now for better or worse. I don't know what we can do with those, but it might be that we could even just set up a meeting, a bit in the future so people can, have their schedules be clearish for that and organize something. But yeah, we would like to know more about what you would like and how we can help. I love your ideas, Catherine, so I want to learn about those for sure. I was wondering if anyone would want to offer up, even in the chat, what you're doing with R that might be different from what Mark and I presented today.
I can speak to what I'm doing with it a little bit, just because it's hard to explain in a chat, but I have been working with the R Fiesta package for small area estimation using FIA data. And I was wanting to experiment with using LANDFIRE as some of the spatial layers for that. And so that's how I first started trying to pull LANDFIRE data into R. Really struggled with using the API. So I'm hoping that I've learned enough now that I can go back and make that just part of my code workflow.
Great. And Catherine, are you using the Terra package or raster or a combo?
I'm trying to switch to Terra and redo anything that uses raster at this point.
Ouch. I went through that, and happy to share code if anything I'm doing would be helpful. It's just so funny. Like, yeah, a few words here and there, a few commas here and there. But if it would help, I'm happy to share my code. And I've learned that it's either the EVC or the EVH, the height or the cover data. The Terra package does not play well with, so I need to debug on that a little bit. So anyways, Catherine, I would love to follow up, and if I can help, I would be happy to.
Yeah, sounds good.
Hey, Randy, in your email signature, you have the place where folks can book a time to meet with you. Do you want to put that link in the chat window?
Yeah, that's a thought.
Your calendar might just fill up, but if we have enough folks that want to meet with you, we could just set an office hour with you and Mark, something that could work far into the future, so folks could make it happen.
Yeah, this is an extremely long link, but it'll be in the chat.
Ryan's been using GGPlot to display a shapefile and geometric point to overlay sample of large woody debris. Cool. Sounds
so
great.
Ryan, something I've heard of people doing would be something similar to that. Now, I don't know how appropriate it is. So this would just be for fun. Would be to overlay that with LANDFIRE fuels data, our fire behavior fuel model, and just see what you get there. Again, that's not like some proper analysis suggestion, but I know that people have wanted to look at a large woody debris for mustelids. Am I saying mustelids properly? Like weasels, martins, fishers, that sort of thing, because they travel along coarse woody debris, especially in the winter, I think.
So it looks
Mark,
like, go ahead, Randy.
Yeah, Mark, have you written this sort of code before, or did you just like think I really need to figure this out and jump in, or how did this work for you?
Yeah, this was my first stab at calling an API from R. So it had a few growing pains. But I do work in R all the time. So it's a familiar process, even if trying to learn the HTTR package is a bit of a beast.
Right. Growing pains. That's a good way to put it. More positive spin on the frustration. Please, others speak up. I don't want to hog the conversation here. I will ask LANDFIRE folks, maybe Henry or Jim or others. I love doing this, and I feel like it's a great way for me to interact with landscapes and dig in deeper. I do think eventually there will be a request for something that supersedes this approach, as some sort of online web map tool where you draw a polygon and you get some sort of report. Has there been any talk of that?
I'll speak up first. Randy, thanks for the question. I have not heard talk about that within the LANDFIRE program itself. Still are working out things like the new LANDFIRE product service and things like that, but it could come up in the future as some additional functionality. But at the moment, I would say no, that we're not thinking about, really forward thinking, ways to deliver the data, although it's an idea that we probably should think about how we can make the data more accessible to more people. But the product service is probably our focus right now in terms of how people access the data aside from the viewer itself.
Yeah, the only thing that I would add to that is the team's been working on a LANDFIRE image service. That's also available through the LANDFIRE product service on that server. There'll be more information shared on that. That's just a recent update that's been completed. And then last but not least, I'll just say, we are talking about LANDFIRE 2.0 featuring where do we go, and how do we not only incorporate new innovations, new science into the products, but then also factor in the delivery of those types of products. So there are new methods and ways that need to be considered to make it more accessible and consumable to users. So that is probably more in that arena than kind of the near term where we're at, but just from some awareness.
Well, I'm kind of interested in the future of R, because a few years ago, I would never have heard of it. Not that I'm a programmer or a coder. All we were thinking about was Python. So what are we thinking about in the future? Are there other options coming down the pike, or is R going to get, it's sort of I don't know what I'd say, standardized or put in a way that, people can access it, more of a community and training? What's the future look like for these kinds of approaches with code?
Yeah, and I think that up until fairly recently, Python was kind of the gold standard in data analysis, but that's been shifting a lot towards R, just because it's the kind of structure of it makes it a lot easier for you to do a lot of different analyses. So it's really kind of taken a strong hold with ecologists at this point. But there are a lot of kind of benefits to it and benefits to Python. So it really, kind of creating if you want to create, a kind of code-based way of interacting with LANDFIRE, I think, having some focus on R and some focus on Python are both good ideas. Yeah.
And isn't that the benefit of Quarto? You can use both those coding languages in that. Because I feel like Quarto just came out of nowhere. It wasn't on my radar, and then Randy's like, "We're working in Quarto now," and I'm like, "What? I have to learn something new. What are we doing?"
Yeah.
I have not. I'm curious if anybody here has done this. I have used Quarto for Python. I've used Quarto for R, but I have not had one Quarto file that did R than Python. I'm not sure why I would want to do that, but curious if anyone's tried that. Or Julia, you can run Julia in a Quarto document. I mean, you can run a lot of different languages through a Quarto document. or
Yeah,
file?
right now I'm using SQL and R in the same Quarto document, which has been pretty helpful, being able to interact with databases. It's really nice, all in one place.
Well, I don't want to drop the idea of creating some sort of community. And again, it doesn't have to be just LANDFIRE, but let's just, if we can't talk about it now, I'm not sure we have any great ideas about how to do that at the moment, but let's keep this going, because that's the key thing here, is that we learn from each other and help each other do more, because that's the way we're going to improve in the future.
I think probably the first step, Jim, is if I have all the list of the attendees today, so I'll send out an email that to everybody that attended, and there will be some options for interacting with Mark and Randy in the future, and engaging with everyone else on the call, because sometimes we don't have ideas in this 1 hour, but things can pop into our heads later at a later point. So let's make sure that if you see an email from me that says like, hey, you attended an office hour on February 22nd, don't delete it. Make sure you open it if you want to stay engaged with us. But I see some folks suggesting Slack, so that's definitely an option. We can set. That's the beauty of this platform, is we can sort of respond to what our users want. And if we hadn't have LANDFIRE office hours, we wouldn't know. So this is cool. Really appreciate you guys being here. And it seems like a lot of people. So our package and Git repository are tied for how do we want to share the code. So yeah, let's get cracking. Maybe some folks on here want to start working on that with us.